in layered soils. So, what is permeability? Permeability is the property of soil to transmit water or liquid, or the other definition is the permeability is the ease with which water or liquid can pass through a mass of soil. यानी permeability प्रॉपर्टी है सॉइल की जिससे सॉइल वाटर की ट्रांसमिशन करता है के लिए, या वो प्रॉपर्टी जो एक मास ऑफ सॉइल को एनेबल करती है वाटर को पास करने के लिए. सो परमेबिलिटी का कॉन्सेप्ट डार्सी ने दिया था. वट डार्स और डार्सी ने ही खुद का एक लॉ दिया है. वट डार्सी डिड वाज ही डिड एन एक्सपेरिमेंट. उस एक्सपेरिमेंट में ही टुक अ सॉइल सैंपल, जो मैंने यहाँ पे वाइट कलर से डिनोट किया हुआ है, and he maintained a constant head difference across this soil sample, and then he kept changing the head difference, the length of the soil sample, which is denoted by L here, the area of the soil sample, that is cross sectional area of the soil sample, denoted by A, and did such experiments to come to some conclusions. He found that the discharge of water through the soil was directly proportional to the head difference maintained across the soil. It was directly proportional to the area of cross section of the soil sample, and it was inversely proportional to the drainage path or the drainage path length of the soil sample. L is the drainage path length, Q is the discharge, and as you can see इस लेवल पे हाई हेड है, हाई प्रेशर हेड है, और इस लेवल पे लो प्रेशर हेड है. So discharge will flow from high head to lower head. So as per Darcy Q, the discharge was directly proportional to HA and it was inversely proportional to L. So the ratio of head difference by the drainage path was denoted by I, which is the hydraulic gradient. और ये unitless है because H भी length का parameter है. I mean head difference is denoted in meters and L is also denoted in meters. So the discharge as per Darcy was given by KIA. This is your Darcy law, जहाँ K कोफिशिएंट ऑफ परमिएबिलिटी या हाइड्रोलिक कंडक्टिविटी है. हाइड्रोलिक कंडक्टिविटी ही आपका कोफिशिएंट ऑफ परमिएबिलिटी या परमिएबिलिटी कोफिशिएंट है, जस्ट लाइक इलेक्ट्रिकल कंडक्टिविटी जो हमने फिजिक्स में पढ़ी थी 11th-12th में. इलेक्ट्रिकल कंडक्टिविटी ये बताती है कि कितना इजीली इलेक्ट्रिसिटी पास कर सकता है कंडक्टर से या मटेरियल से. उसी तरह हाइड्रोलिक कंडक्टिविटी ये बताती है कि कितना इजीली वाटर पास कर सकता है सॉइल सैंपल से. सो यूनिट्स ऑफ के आर सेंटीमीटर पर सेकेंड और per second. वाई आई हैव नॉट रिटन हियर मीटर पर सेकेंड इज बिकॉज इतना फ्लो नहीं होता है सॉइल में. मीटर पर सेकेंड का मतलब 1 सेकेंड में 4-5 मीटर पानी फ्लो कर जाए तो वो फिर सॉइल है या क्या है? वो पाइप थोड़ी है पंप के साथ लगी हुई. सो हेंस यूनिट्स जब भी आप के यूजुअली फाइंड करेंगे तो यूनिट्स विल बी लेस. इट कैन बी मीटर पर आवर, इट कैन बी मीटर पर डे, ऐसा हो सकता है, बट मीटर पर सेकेंड होना बड़ा कम ही चांस है. फिर वो सॉइल नहीं होगी, दैट वुड बी समथिंग एल्स. Now consider this as a rectangular soil mass and I have drawn there a cross section जिसे मैंने शेड किया हुआ है इस rectangular soil mass में. इस cross section को अगर हम zoom out करें, let us suppose Ant-Man goes in and zooms it out, तो Ant-Man को क्या मिलेगा इस cross section में जाते हुए? He will find that इस cross section में soil solid के particles हैं, ये जो मैंने गोल गोल बनाए हैं, और बाकी सारा पेंडिंग एरिया इट हैज़ voids, and void can have either water or air as we are aware of it. तो एंटमैन जब गया इस सॉइल सैंपल में तो उसे ये दिखा कि सॉइल के क्रॉस सेक्शन में तो सिर्फ सॉइल पार्टिकल्स और voids हैं, तो वाटर फ्लो कहाँ से करेगा? अब सवाल ये आता है. सो नाउ इज द वाटर पासिंग थ्रू द टोटल एरिया? Total area means this whole area, or is it passing through the voids? Of course, water will easily flow through the voids. Soil particles से तो उसे hindrance मिलेगी solids से, soil solids से. So it is passing through the through the voids, not total area. But डार्सी ने जब अपना एक्सपेरिमेंट किया और जब डार्सी ने अपना लॉ दिया तो यहाँ पर ए उसने क्रॉस सेक्शनल एरिया लिया है, यानी कि पूरा एरिया. सो हेंस टू टाइप की, तो इसीलिए दो वेलोसिटीज आती हैं डार्सी लॉ के बाद. एक तो वो वेलोसिटी जो टोटल एरिया के थ्रू काउंट की जाती है, उसे डिस्चार्ज वेलोसिटी बोलते हैं. और एक वो वेलोसिटी जो वॉइड्स के थ्रू जाती है, उसे हम सीपेज वेलोसिटी बोलते हैं. सो टू मेंटेन कंटिन्यूटी, क्योंकि डिस्चार्ज तो कांस्टेंट रहेगा, मास ऑफ कंटिन्यूटी तो रहेगी, जितना वाटर बाहर रहेगा उतना ही वाटर अंदर आना चाहिए. सो वी डिड्यूस अ मैथमेटिकल इक्वेशन टू फाइंड आउट अ रिलेशन बिटवीन डिस्चार्ज velocity and seepage velocity. So Vs is our seepage velocity, which is through the pores, and V is our discharge velocity, which is also sometimes known as superficial velocity or average velocity. So from this continuity equation, we'll get that Va is equals to Vs Av. So hence we can relate the seepage velocity and the discharge velocity by Vs equals V by Av. One second. Vs equals V by A by Av, or V, I think I have done some mistake. So Vs will be Va by Av. इसे हम लिख सकते हैं Av by A, because एक यहाँ से ऊपर जा सकता है. So and this ratio Av by total A can be written as the porosity, because porosity is volume of voids by total volume. Now if the लेंथ इज कंसिडर्ड टू बी यूनिट, अगर लेंथ को हम यूनिट मान ले, 1 मीटर मान ले, तो दिस कुड बी रिटन एज ए वी टाइम्स 1 एंड वॉल्यूम एज वॉल्यूम एज टोटल एरिया टाइम्स 1. सो porosity can be written as the ratio of AV by A. Hence, the seepage velocity can be written as V by N, where N is the porosity. AV is the area of voids and A is the total area. अब जो पहला सवाल आता है वो है सीवेज वेलोसिटी इज डैश देन डिस्चार्ज वेलोसिटी. फर्स्ट ऑप्शन इज सीपेज वेलोसिटी is always greater than the discharge velocity, A. B is both depending on value of porosity. I mean, it says that it can be both seepage and the discharge velocity depend on porosity, which is wrong. B तो गलत है. I mean C तो गलत है. B option is always smaller, Vs is always less than V, and the D option says Vs is equals to Vv. So इस क्वेश्चन को सॉल्व करने के लिए we'll have to see the formula that Vs is given by V by N, where N is the porosity. Now the value of porosity, as we know from the basics of soil mechanics, n is always less than 1. n 1 नहीं हो सकता, because जैसे कि हम जानते हैं porosity volume of voids by total volume है. n equals to 1 means the whole volume, the total volume of soil mass has nothing but voids. तो फिर वो soil ही कैसे रहेगी? So hence n will always be less than 1. So if n is always less than 1, then that means Vs will always be greater than V. Hence the correct answer would be seepage velocity will always be greater than the discharge velocity. Okay. Now comes the next question. In a soil sample with porosity 0.5 and with a cross-sectional area 10 centimeters square, when flow was taking place under a hydraulic gradient of 0.5, hydraulic gradient means I, cross-sectional area means A, the amount of water collected is 60 seconds. That's the time is 600 centimeter cube cc, that is 600 centimeter cube. What they have asked us to find out is permeability, discharge velocity and seepage velocity. Let us first see the parameters they have given to us. They have given us the porosity, they have given us the cross sectional area, they have given us the hydraulic gradient, which is denoted by the head difference divided by the drainage path. They have given us the time, which is 60 seconds. They have given us the volume, which is 600 centimeter cube cc. Now first thing I'll do is I'll find out the discharge. Discharge is given by the volume divided by the time taken. So that would be 600 centimeter cube divided by 60 seconds, and then it would be nothing but 10 centimeter cube per second. That would be our discharge. Now we know, as per Darcy, because we have to find out, the first thing they have asked us to find is the coefficient of permeability, K. We know that discharge is given by QIA. So now we have Q as 10 centimeter cube per second. K is something we have to find out. I was given as 0.5 and area given was 10 centimeter square. So the K we get here is nothing but 0.5 goes here, it becomes 2 centimeter per second. So the coefficient of permeability is 2 centimeter per second. 2 centimeter per second. The next thing they have asked us is discharge velocity. Now let's see discharge velocity. For discharge velocity, we know that Q is nothing but Q is area into velocity. Therefore, velocity can be found out by the ratio of Q by A. Q we have now is 10 centimeter cube per second, and the area we have is 10 centimeter square. Yes, 10 centimeter square. So the velocity we are getting is 1 centimeter per second. This is our discharge velocity. This is not the seepage velocity. What they have asked us now, the third point is seepage velocity. So how will we find out the seepage velocity? It's very simple. Well, simply Vs is given by the discharge velocity divided by the porosity. Discharge velocity is 1 centimeter per second and the porosity was given as 0.4. So 1 divided by 0.4, that comes out to be 2.5 centimeter per second. Now from the numerical itself, you can see that Vs is 2.55 centimeter per second, while V, the discharge velocity, is 1 centimeter per second. Hence, Vs is greater than V. So you will always remember that the seepage velocity is always going to be greater than the discharge velocity. Now comes the next question. Now this question was actually asked in GATE. The concept was simple, except that we have to use a bit of mathematics in it, and that's what GATE questions are all about. It's a bit, you must have the clarity of concepts, but you also should be good in applying the aptitude, applying some mathematical skills in the problems. So in the given question, they have asked us to find the discharge meter cube per meter. Now this statement is very important, meter cube per day per meter. When it is said per meter, it means for a unit length. Through a sand layer which has a width of 5 meters. This is your sand layer, okay, and this is 5 meter width. K is given as 3 meters per day, inclined at an angle 60 degree to the horizontal. Here you can see that the inclination with horizontal is 60 degrees. The piezometers placed at A and B. Piezometers are placed at A and B. The horizontal distance between the two piezometers is 3 meters. And the difference in water level of these piezometer is nothing but, that is H is nothing but 3 meters, the difference. between the two parameters. What have they asked us is the discharge. Now from Darcy we know that discharge can be calculated by KIA, that we know of. Now let's see. First of all, we have to do is we have to find out. Let's see. K is given, I is given by H by L, and A is your area, that is given by width times L. Now since they have asked us discharge meter cube per day per meter, that means the discharge here would be Q by L, or L would be 1 meter. So the discharge meter cube per day per meter can be calculated by K times H, which is 3. L is the discharge path length. Now here the discharge path length won't be a straight line. पानी सीधा नहीं travel करेगा इसमें. The water won't be traveling like this. No. The water will be traveling something like this. Hence discharge length would not be 3. We would have to find out it by using trigonometry. So in this figure you can see that I have first drawn a horizontal line and then the assumed discharge path across A and B. This is also making theta, which is 60 degree with the horizontal. Now we know that from A to B, let me show you this triangle. ये हमारा ट्रायंगल है, ये कहीं पॉइंट A है और ये पॉइंट आपका B है. X which is equals to L, ये हमारी एक्चुअल डिस्चार्ज पाथ है जो फॉर्मूला में हमें यहाँ यूज करना है. इसे मैं स्मॉल l डिनोट कर देता हूँ ताकि कंफ्यूजन ना हो. ये लेंथ ही है बट L इज डिस्चार्ज, कैपिटल L इज डिस्चार्ज path I mean. So this is your theta, which is 60 degrees. Now the horizontal distance between A and B is given by 3 meters. They have mentioned it in the question. Horizontal distance between A and B as 3 meters. So now we have to find out the actual discharge path. How can we find it? We know that cos theta is base by hypotenuse. Hence cos 60 degree would be base 3 meters by x, and x would be 3 by cos 60 degree, which will come out to be 6 meters. So therefore the discharge path here would be nothing but 6 meters. Then we have the width, which is given by 5 meters. Hence the discharge would be KIA, which would be 3 meters per day into the head difference between the 2 points was given to be 3 meters. I would be H by L, that would be 3 by the drainage path. Drainage path is what? 6 meters. And the area is B into 1, that is your width. So 3 by 2, 15 by 2, the answer comes out to be 7.5 meter cube per day per meter. Sorry guys, कॉल आ गया था मुझे अटेंड करने के लिए, तो I had to attend that call. So the discharge is 7.5 meter cubes per day per meter. Now let's see, अभी तक जितने भी हमने केसेस पढ़े हैं, be it this question or other question, or in fact the Darcy law that we studied, all of this was just for a single layered soil. That means if it was sand to sandy थी, it was silt, it was silt, if it was clay, it was clay. So what if what will happen if we have multi-layered soil? That means we have, say, silt here, and let us say we have clay here, and let us say we have sand here. So it's a multi-layered soil. So how will the discharge flow through such multi-layered soils? How will coefficient of permeability be affected in such cases? Now we'll see that. Okay. Now, multi-layered soil or layered soil and equivalent coefficient of permeability. So what we do in multi-layered soil actually is we convert this whole multi-layered system of soil into one single layered soil which has a equivalent coefficient of permeability. That means K equivalent is equal to K1, K2, K3. So the three different soils having three different permeability will be converted into a one single layered soil having one coefficient of permeability, and the discharge will be kept constant. Now there are two types of layerings. The first one is horizontal flow. This is one example of horizontal flow through a multi-layered soil. As you can see, a head is maintained across the layer of soil, across the sample of soil, which is multi-layered, and this is how the discharge will go through this soil. The total discharge, of course, would be kept same. The second position is this one. Again, a constant discharge is maintained across the sample of soil, and this is how the flow will take place. Now, there is one misconception amongst someone who is new to this concept, that we think horizontal का मतलब एक straight line, कुछ ऐसा कुछ, अगर तो फ्लो ऐसा हुआ तो वो आपका हॉरिजॉन्टल फ्लो होगा परमेबिलिटी में, और अगर तो ऐसा हुआ जो कि नॉर्मली हम वर्टिकल लेते हैं तो दैट वुड बी अ वर्टिकल फ्लो. बट नहीं, ऐसा नहीं है. द कॉन्सेप्ट इज, अगर पानी की लेयर्स, पानी का फ्लो पैरेलल हो layer of soils, like as you can see, this is your layer of soil, one layer of soil, this is your second layer of soil, this is your third layer of soil, and पानी का बहाव भी पैरेलल है इन सॉइल लेयर्स को, तो ये हॉरिजॉन्टल होगा. सिमिलरली अगर इस वाली केस में आप देख सकते हैं, पैसेज ऑफ फ्लो इज लाइक दिस. This is parallel to the layers of soil. Hence, for horizontal flow, what matters is the flow should be parallel to planes of bed, or the flow should be parallel to the stratification, or the flow should be parallel to the layers. That means irrespective की direction of water ऐसा है या ऐसा है, if it is parallel to the layers of soil, then it would be horizontal flow. So let's see. Here is an example of multi-layered soils having coefficient of permeability K1, K2 and K3.